Yeah, we'll continue. So I've already started with the preparation part in the last class. So methods of preparation, in that first method I've discussed with you. Okay, the first method is from alcohol. So the general formula of alcohol you have seen. General formula of alcohol is ROH, which is made to react in the presence of any hydrogen halide. Okay, so here I have taken HCl as an example. You can take HCl, or it can be generally just HX. Okay, ROH is made to react with the HX generally in the presence of a catalyst, that is anhydrous zinc chloride will act as a catalyst just to break this R and O bond is there. No, to break that easily, this catalyst will be helpful and make the reaction to proceed in the forward direction. So ROH plus HX will give you R. I've told you, you do the charge separation here, then things becomes easier. Okay, so here R is positively charged, partial positive charge is there on the R group, and oxygen is carrying partial negative charge. Hydrogen carries partial positive charge, and halide will carry partial negative charge. So H and then OH will go out, water will go out, remaining is what? R and then X. So RX will be formed, that is alkyl halide will be formed, plus along with that water will be formed as a side product, okay, byproduct. And one example you can take R as any group. In the class I've given you CH3OH, here I've taken another example, okay. And this process, no, whole process has a name. This process is called as Groove's process, okay. So this process, you can write it down if you haven't written what is the name of it. It is called as Groove's process. Even in your book it is not given, okay. In the book also it is not mentioned, so it's better if you mention that this process is called as Groove's process. An example is here, okay. So C2H5 is given here, C2H5 and OH, that is ethyl alcohol. So if you take ethyl alcohol with HCl, it will give you ethyl chloride plus water will be formed, okay. This will give you ethyl chloride. So this is another example. At least one example you should be able to write. Or in case in the exam, if they give you C2H5 and HCl, you should know how to complete the reaction. Okay, so first one we have completed. Now I'll proceed with the second one. There only from alcohol itself, you are having around 6 reactions, okay, from alcohol itself. So let me proceed with that. Okay, next reaction is when alcohol is made to react with the PCl3, okay. PCl3, or generally you can take PX3. PCl3 is a name of this is phosphorus. This compound is phosphorus trihalide. Okay, this is phosphorus tri. Now here chloride is there, so I'll write chloride. X3, if you are writing, it will be trihalide. But if you are taking chlorine in particularly as an example, it will be phosphorus trichloride. Okay, now can you tell me which will be having positive and negative charge here? R will be having a partial positive charge, correct, no? And always remember students, the starting one, when we write a salt also, NaCl, when you are writing, starting one is always positively charged, no? And followed by you are having a negative charge. Always cation comes first, followed by the anion. So it is understood that the starting one should be carrying a positive charge and O will be carrying a partial negative charge. Similarly here phosphorus will carry partial positive charge and chloride will carry partial negative charge. Okay. Now what is the valency of phosphorus here? Anyone who could tell me what is the valency of phosphorus here in phosphorus trichloride? What is the valency of phosphorus here? Yes. Correct. Very good. Yeah, 3. And how do you identify that it is 3? Because you can see here it is crossed and given, no? Like see, if I give you aluminium chloride. Aluminium chloride, because it is combining with 3 chloride and you know chloride valency is only 1. So if 3 chloride has combined, that means aluminium here is 3 plus charge and chloride is minus charge. So since there is 3 positive charges, it will require 3 negative charge to get satisfied. Okay, 3 plus charge is there. Similarly over here also phosphorus PCl3, here P is 3 plus charge and chloride is minus charge. Okay. So phosphorus valency is 3 plus. Okay, just to do the charge separation, I've put plus and minus there. Otherwise, phosphorus is plus 3 charge. Now, if you cross and write the product, what will you get? After crossing and writing the product, you will get RCl, correct, no? RCl, because R is plus 1 plus it is, and Cl is 1 minus. So, you'll get RCl plus. Phosphorus will combine with the OH. Okay, how many OH it will combine? See the phosphorus valency. Phosphorus valency is 3 plus. If 3 plus is there, it can combine with 3 OH minus. Okay, so this phosphorus, which is 3 plus charge, it will combine with OH minus. Then whatever compound you are going to get, I will be crossing it here, and then you will get POH 3 times. Okay, so POH 3 times can also be written like this, H3PO3. Okay, in your book you will find this acid being written as H3PO3. Okay, otherwise it is P, which is combining with the 3 OH group. Okay, so you can write it like that. You can write it as POH3. This is just to make the things easy for you. I am telling you that crossing thing. Okay, or it can be written as H3PO3. Is this reaction clear what I said? When alcohol is made to react with the phosphorus trichloride. Okay, in alcohol you do the charge separation. R is positively charged and O is negatively charged. Phosphorus is positively charged, chloride is negatively charged. You just cross them. You get the R with the Cl group and phosphorus with the OH group. Since phosphorus here is with plus 3 oxidation state, it will combine with 3 OH minus. So you get POH3. Now write one example for this. I'll take one more example for this. You can take ethyl group. Instead of R, I'll be taking C2H5. Okay. Instead of R, it is C2H5. Rest everything remains same. Only your R group can be changed. So it is a general reaction. You can prepare any other alkyl chloride using this. You can prepare methyl, ethyl, propyl. So we write generally as R. Okay, so C2H5OH plus PCl3 separate them, separate the charges. This C2H5 will go with Cl and P will combine with the OH. Okay, so your product will be C2H5Cl plus I'll just write H3PO3. You understood, it should be like P with OH 3 times. So it is H3PO3. Okay, you can balance this. But in organic, if you don't balance the reaction also, you will get marks. Okay, so you don't have to worry much. You can balance here. See, 3 chloride are there, no? So that means here I'll get 3 C2H5OH, and here you are having 3 C2H5Cl. So that means here also I should multiply by 3. Okay, so you write the name here first. Copy down this, students. Write the name below that. H3PO3, yeah, it is phosphorus acid. Okay, the name of this H3PO3 is phosphorus acid. I'll give the name. Write down the name below this. Okay, C2H5OH is ethyl alcohol. PCl3, anyways, I've written here up. Phosphorus trichloride. C2H5Cl is ethyl chloride. And H3PO3 is phosphorus acid. Phosphorus, okay? Not phosphoric. Phosphorus acid. Yes. For everyone, is the screen clear? Are you able to see the screen? Yes, no? Yeah, okay. In case if you have any network issues, you please rejoin once again. Yes, over. Second one is done. Alcohol with PCl3 gives you RCl plus phosphorus acid. Okay, let me go for the next one. Okay, next is alcohol ROH with the PCl5. PCl5 is phosphorus. This is phosphorus pentachloride. Phosphorus pentachloride. Okay, now see the reaction proceeds in a little different way here. So how will you remember here how to write the product? See, now you know you are preparing alkyl halide here. So whenever you see one chloride and you find R group there, always prepare that alkyl chloride and keep it aside. Okay. Since we know that we are doing that preparation R and then Cl, so you combine that to RCl and write it separately. Okay. Now during the process, PCl5 is highly reactive compound. Okay, which is having trigonal bipyramidal shape. See, if you remember the shape of this is how it is. You are having Cl group. 3 Cl group is on the plane and 1 Cl group is above the plane and 1 Cl group is below the plane. Okay, and due to that, there is a strain in the bond, and due to this reason, the bond of this upper one and lower one is, it's little longer. So they are highly reactive. So it will easily lose this chloride. 2 chloride groups are there. No, it will be lost easily for the reaction. Okay, so you can remember in that way. So if one chloride goes, that chloride is negatively charged, no? If this one chloride goes, then it has to combine with the positive one. So it will combine with one R group. Now another chloride is also there, okay? So that another chloride you can take with the hydrogen, because hydrogen is also positively charged. So you remove this hydrogen and combine with another Cl group, okay? First Cl I said you take with the R group, another Cl you take with the hydrogen. So in first case you will get RCl as the product, and the second one will be HCl. Now whatever is remaining, you combine that and write together. Okay, so what is remaining now here? Phosphorus is remaining, one oxygen is remaining. How many chloride groups are remaining? One phosphorus is remaining, one oxygen is remaining, and then how many Cl groups are remaining? 3, right? Yes. So what you will do is you will combine them and write. Okay, so here you will get POCl3. POCl3 will be the product. Okay, I'll repeat this once again to remember this reaction. See, you are taking alcohol ROH. Okay, I'll repeat this once again. So you are taking alcohol, that is ROH, and combining with phosphorus pentachloride. So phosphorus pentachloride structure is like this, where you are having 3 chloride on the plane and you are having 1 chloride above the plane and 1 chloride is below the plane. Okay, and these chloride groups which are present, which is above and below the plane, they are highly reactive. Okay, these are highly reactive. So if they are highly reactive, that means they will like to break their bond easily. Highly reactive ones, bond length is quite longer, so it will go out easily, it will react easily. Okay, so if chloride is going out, it is minus charge, so this minus one will try to combine with the positive, no? So your R group is positive, so this one chloride, you remember, combines with the R, giving you RCl as the product. Okay, one more chloride group is there, so that one more chloride group, what you will do is combine them with the hydrogen, so you will get HCl. Okay, so after this is over, you will be left with the P and 3 chloride group is there, plus there is oxygen. This forms a compound that is POCl3. Okay. General reaction I've given. With example I'm not giving because it is understood every place where R is there, you can replace either by CH3 group or you can take C2H5 group. Okay, so I will not be giving you example. Yes, done. Is this reaction clear, students? And we are not going into the mechanism part, so I'm just telling you the way you will remember the product, how to write the product. Okay, let's go for the next one. Here below itself I will be writing. The next one is little important one. Okay, because many time it's been asked in the exam also. Plus industrially also it is very important. Okay, where alcohol is made to react with the SOCl2. The compound is SOCl2. SOCl2 is also called as a thionyl chloride. Okay, this compound is also called as thionyl chloride. So the reaction you do almost in a similar manner, the way I told you with PCl5. Okay, so what you will do here is, when you see the R group, combine this R group with the Cl. Okay, R you combine with the Cl, so you'll get RCl. Okay, and then there is one more chlorine group present. That one more chloride which is there, you combine with the hydrogen. Okay, so you will get HCl. Now what will be remaining after that if RCl has combined, R has combined with one Cl and H has combined with one more Cl. So this Cl2 part has gone. What is remaining here? Sulfur is remaining and then you are having, yeah, 2 oxygen, correct. Sulfur dioxide, yes. So SO2 will be remaining. So sulfur dioxide will be formed during the process. Now I said industrially this reaction is very important. Why it is important? Because here HCl is formed, no? HCl students, I know in the lab you have seen HCl in the gas for this thing liquid form, but HCl by nature it is a gas. Okay, HCl is being passed through the water and the hydrochloric acid solutions are prepared. Otherwise, HCl by nature it's a gas, and sulfur dioxide also you know that it is a gas. So during the reaction, what will happen? These two gases will escape. So only RCl which is there that will be existing. Okay, these two will escape out. So it's easy to do the separation and it's easy for them to prepare these kind of compound. Otherwise, most of the time two liquids will be formed. If two liquids are formed, you have to separate those two liquid, which is again a double work for them. Okay, but during the reaction, if only one is being formed and the others are in the gases form, they will escape out easily. So separation becomes easier. So I said industrially this reaction is preferred. Okay, that is alcohol with thionyl chloride, because the products which are formed, they are in the gases form. Okay, for this at least you can remember the example also. It's better to study with the example. So here R group you can take C2H5OH, ethyl alcohol. Okay, so ethyl alcohol or ethanol combines with thionyl chloride, that is SOCl2, giving you C2H5 and then Cl. Okay, C2H5Cl, ethyl chloride plus hydrochloric acid HCl plus sulfur dioxide. Okay, only R group I have taken as C2H5, only that will change. Rest everything remains the same. Okay, so copy down this. This you mark as very important. With thionyl chloride, even in the exam question can be asked like this. When alcohol is made to react with thionyl chloride, what is the product formed? Okay, and write the equation for that reaction. Yes, over. This much is done, students. And see, organic you have to practice. Only when you practice the reaction, you will be able to understand. Okay, organic is almost like your maths. Every time you need to practice, only then you will be able to remember. And these reactions are like that, okay, where you have to remember what are the reactants and what they will give you. So every time mechanism we can't do, because you know we will not be able to complete the whole thing, and it's not important for your syllabus. Wherever things are required to be told, I will be telling you. Okay, wherever just reactions are supposed to be completed, you just remember like that. Yes, I'll proceed with next one now. Okay, next preparation from alcohol itself. Alcohol when made to react with the NaBr and sulfuric acid, that is H2SO4. NaBr and sulfuric acid, then what will be the product formed? Okay, so now NaBr and H2SO4 is taken. So during that time, first NaBr and H2SO4 will react. Okay. So see how they will react. NaBr and H2SO4 will react. You know, acid is any substance which will give you H plus ion easily. So first one H plus ion will be given. This H2SO4, it's a dibasic acid because they can give you 2 H plus ion during the process. Okay, so first it will give you 1 H plus, then it will give you second H plus. Okay, so here you break them in that form. See, Na if I am breaking, I will get Na plus and Br minus. No doubt in that. H2SO4 also you try to break. You will get H plus ion and then remaining will be HSO4 minus ion. Okay, so when these two NaBr and H2SO4 is made to combine, see what will be the first product which will be formed. This Na plus is there, no, that will combine with the HSO4 minus, and your H plus will combine with this Br minus, forming HBr. So the product which you will be getting first, that will be HBr plus NaHSO4. Okay. Now this HBr will further react with your, okay, this will be made to react with alcohol. So this ROH, alcohol, now you bring that alcohol into picture, okay, once this HBr and NaHSO4 is formed. So now this alcohol will combine with HBr. If alcohol combines with HBr, what will be the product? You can tell me now after this. What will be the product formed? R over here, yes, positive, OH is minus, H is positive, Br is minus, yes, very good, correct. So R will combine with Br, no? So you will get RBr plus H will go with the OH. So it will give you water, yes, very good, correct. So you will get RBr plus H2O, understood? So overall, if I have to write this reaction, okay, overall reaction if I have to write, this HBr and HBr will get cancelled, no? Because they are just produced during the reaction and then they are consumed by the alcohol group to form RBr plus water. Agree, so I can cancel them. They are not there as the end product. They were just formed during the process. So if I cancel them, what will be I left with? I will be having only alcohol group, ROH group plus NaBr plus H2SO4. That will give you finally what product? RBr plus NaHSO4 and plus water. So this will be the final product. Okay, RBr NaHSO4 plus water. So that I'll write here. Okay, so what you're going to get is RBr plus NaHSO4 plus water. Okay. Now, if this is little difficult for you to remember because I gave you in two steps. This is how the reaction proceeds. Okay, first NaBr is made to react with sulfuric acid so that it will produce HBr, and NaHSO4 is a salt. Okay, so that salt anyways will not react. HBr is more reactive. So HBr will react with the alcohol immediately to give you RBr plus water. Still, if it is difficult, you know sulfuric acid has a name for it. What type of agent is sulfuric acid? What type of agent is sulfuric acid? You have studied in first year, if you remember. Sulfuric acid, if it falls on skin, what happens? It leads to burning sensation. Okay. That burning sensation is because of loss of water molecule which is happening. So these sulfuric acid is also called as a dehydrating agent because it has a tendency to make loss of water molecule. So you can remember in that way. Okay, if it is difficult for you to remember this reaction in two steps, so I am telling you what is another trick for you to remember. Sulfuric acid is a dehydrating agent. Dehydrating agent means which will remove water, correct, no? So you have to remove water. Now if you have to remove water, you need H plus and OH minus. So you take that H plus from the acid and you take the OH from the alcohol. And whenever you see one Br and R group, your first job is to combine them and form the product. Okay. So R and Br will combine together. This R and Br will go together. Okay. Always whenever you see one R group and whenever you see one halide, you just combine them and write the product. Like, even though if you don't remember other things what it has to be, at least this you can write and finish it. Okay. So RBr. So I told you sulfuric acid is a dehydrating agent. So one H plus and one OH. So water will be going there. So what remains? Remaining is only Na, no? Na and one HSO4 will be remaining. So that you combine together and write NaHSO4. Okay. This is another way to remember. Yes, clear what I said? Yes. Okay. Fine. Okay. Let me continue then. Okay. Good. Okay. One more reaction now. Sometimes, see this coming to your phosphorus trihalides are there. No, trihalides in that phosphorus trichloride is little stable, whereas phosphorus tribromide and phosphorus triiodide, due to their overlapping, because the size is larger, no, iodine and bromine, so overlapping is little difficult, so these are not very stable compound, so it will not be stable existing as a salt. So if you want still that alkyl bromide and alkyl iodide to be formed, what we do is, one more way to prepare that is, they take directly alcohol is taken and made to react with red phosphorus. Red phosphorus in the presence of any halogen, okay? Like if you want to prepare bromine, you pass bromine gas. If you want iodine, you take iodine there, okay? So if you like, you need alkyl iodide to be formed, you take that halogen as iodine. You want alkyl bromide to be formed, you take that halogen as bromine, okay? So that is a change which has been done. Due to why I'm saying is because this PBr3 and Pi3 is not that stable. So it will decompose. Due to that, there is a problem. You can't prepare them and keep it and then use it for reaction. It will not be giving you that sufficient amount of product. So during the process, what you can do is directly you take the phosphorus and make it to react with the halogen. Okay. So then the product form will be your alkyl halide. Okay. This much if you write is enough, because your textbook also gives you only this much. Other side compounds, they are not asking you to mention. Okay. This is the last reaction which is there by the alcohol. So copy down this. Okay. Where this X can be either bromine or it can be iodine. Okay. This X group can be either bromine or iodine. In this case, it has been done. Should I repeat this once again? Since voice was breaking, should I repeat this once again? Okay, I'll repeat. See. Okay. See, phosphorus trichloride salt is quite stable salt. So you can take, if you want to prepare alkyl chloride, you can directly take phosphorus trichloride and make it to react with alcohol. Okay. But here in the case of phosphorus tribromide and phosphorus triiodide, these are not very stable compound. Okay. So you can't prepare these salts and keep. This will decompose. So what is another method for us to do is, if you want to prepare alkyl bromide and alkyl iodide, what we do is direct reaction. Okay. Like when you want, that time you prepare and keep. So directly they take red phosphorus and make it to react with that particular halogen which you want. So then during the process, it will give you PBr3 and immediately it will react with the alcohol. Okay. Or if it is iodine, it will immediately form Pi3 and then it will decompose immediately and react with the alcohol to give you alkyl iodide. Okay. Am I clear now? Did you understand what I said? So alcohol is directly made to react during the course of the reaction. It is not prepared and kept initially, because being unstable, it will decompose. Due to that reason, when it is required, that time only you prepare. Okay, so red phosphorus with the X. That X can be either bromine or it can be iodine. Okay, which will give you directly alkyl halide. So that halide again can be either alkyl bromide or alkyl iodide. Other compounds are also there, but then it's not mentioned in your book, so even you don't have to mention it. Okay, this much if you write is enough. If question is given like this, you just write Rx is the product. Okay, understood now what I said? Okay, so alcohol preparations are over. Okay, from alcohol, whatever alkyl halide we have prepared, so that has been done. Now we'll proceed with the next one. Okay, I'll continue with the next. Okay, next is from hydrocarbon. Next preparation is from hydrocarbon, that is by free radical halogenation. Okay, the reaction is by free radical halogenation. This you had even in your 10th standard, if you remember. You're taking hydrocarbon and making it to react with any halogen. We will take chlorine here. It's easy to understand with chlorine. In the presence of sunlight. Do you remember this? Even in first year also, I've repeated the same thing. In the hydrocarbon chapter, if you remember. Methane, okay, when methane is made to react with chlorine. In the presence of sunlight. In the presence of sunlight, it can be even UV light, okay? UV light. Then this chlorine atom which is there, they undergo homolytic fission. This chlorine, okay, I'll write the bond here. Chlorine is having a single bond, no, with another chlorine atom. So during the process, means when the sunlight falls on this chlorine atom, they undergo homolytic fission. Okay, homolytic fission is where, see, one bond is having 2 electrons. This one bond has 2 electrons, so it will break down equally. One electron will go to one chlorine and another electron will go to another chlorine. Okay, that time you'll get chlorine with 1 electron here and another chlorine with 1 electron here. These are called as what? These are called as free radicals. These are called as free radicals, and free radicals are highly reactive, very, very reactive compounds, and very dangerous also, because it will continue the reaction in the chain formation. Okay, like a chain reaction, it will continue till they are satisfied. No, like that it is. So here this radical will come and attack this methane group. Then methane will undergo breaking. Okay, so they will also undergo breaking. See here, this chloride, what it will do is it will go and take hydrogen. So then this hydrogen will break the bond with the carbon. So one electron here, one more electron here. So hydrogen will be giving one electron, and this CH3 is there, no? That will be left with one electron. Okay. And here you are having Cl dot. These two will combine with one another, forming what? HCl. And there is another chloride radical. So that another chloride radical will combine with this carbon like this to form a bond. So what will be the product formed here? Understood what I did just now? When the sunlight falls on the chlorine atom, okay, the chlorine molecules will break down. Homolytic fission happens. Homolytic means where there is equal distribution of electrons. Okay. Heterolytic means where all the electrons, shared pair of electrons will be taken by one species. Now here both of them are of same kind, no? So then equal breaking happens. Okay. That happens only in the presence of sunlight. If you provide sunlight or heat, okay, then it happens like this. So it will break out in this fashion and it gives the free radical. So that free radical being highly reactive, it will go and break the bond over here between the methane. Okay, so this one H will come out with one electron. Okay, and it will try to combine with this Cl. So it will form HCl. So HCl will be formed here, plus what is another one remaining? CH3 dot. So that has to become stable, no? So it will combine with another chloride radical. It will give you CH3Cl. And like this, the reaction can continue till all the hydrogen has been replaced. This we have done before also. You are able to remember? Methane combines with chlorine, giving you methyl chloride. Methyl chloride or chloromethane if you are writing IUPAC name. Okay, now see, in your book, what example they have given is of butane. So if butane is given, then how the reaction will continue? See here. Similar fashion, you have to continue that reaction. So I have here CH3, CH2, CH2 and CH3. Okay. Plus when you are taking chlorine in the presence of sunlight, or UV light, okay, then you break this chlorine. Actually, what we have done, we just removed one hydrogen and replaced by the chlorine. No, so same thing you do here. Okay, mechanism isn't important. So just do the whatever I explained was a mechanism part. Okay. So now you just see how to remove it. You remove one hydrogen and replace it by one chlorine. So what will be the product formed? See. CH3, CH2, CH2, and then here one hydrogen I am removing. I have CH3 here, correct? So you remove one hydrogen. So if I remove one hydrogen, I'll be left with CH2. And that hydrogen is replaced by chlorine. So this will be the product formed. Okay. So that is one case. But is it a guarantee that only this hydrogen will be replaced? Even this hydrogen can be replaced, correct? Even the second hydrogen, okay, the second hydrogen can also be replaced. So that can also be a product formed. Okay, that will be another product. So CH3, if that is a product, see how it will be. CH3, CH2, then CH, that Cl I'll put here. Okay, one hydrogen I'm reducing from here. The second carbon to which that hydrogen is attached to, that hydrogen can go out. So I'm removing one hydrogen from there, and in that place I'm putting one chlorine, and remaining is CH3. So this will be another product. Okay, and the reaction doesn't stop here. If there is more amount of chlorine, all of these hydrogen can be replaced. So you will get either a monomer, you can get a dimer, even you can get a polyhalo compounds. Okay, so you will get variety of product here. So due to that reason, this particular reaction is not done industrially. We don't make use of this process to prepare any haloalkane, because you are having variety of product, and if you get variety of product, you have to separate them, which is again a double work. Okay, so this process is not used industrially due to formation of different isomeric product, or polyhaloalkanes are being produced. Okay, is this understood, students? This reaction is understood what I said? I have explained from the basic. First I have explained with methane, and when methane reacts with chlorine, it undergoes homolytic fission, generates a free radical. That free radical will go and attack, and then they give rise to methyl chloride plus HCl. So similarly over here, you take butane. This is butane as a product. So butane, when made to react with Cl, there will be another product also, two molecules of HCl. Okay, because we have removed H from here and H from here, no? This also can be two molecules, but in organic, balancing is not that important. So everywhere you will just see they just write the reactant and they just write the product. They don't do the balancing part, and sometimes they don't even mention the side product. But if you want to know what is a side product, I have given here. Okay, it is two molecules of HCl which is formed side, and two molecules of butane will react. Is this understood, everyone? Yes, no? Okay, good. Fine. You can write the name of this compound. Write the name also. Only two products are mentioned because your textbook also is mentioning only two. Otherwise, there are many other products also being formed. Okay. What will be the name of first one? This is chlorine here. Don't count them as carbon. This is chlorine. So first carbon is this. 1, 2, 3, and then 4. So first carbon, there is chlorine attached. So it will be 1 chloro, 4 carbon, so butane. So 1 chlorobutane. 1 chlorobutane is the first compound. Come to the second one. 1, 2, 3, and then 4. Second position, there is Cl group. So it is 2 chlorobutane. Okay, this is the second compound. So you can write down the names there. Now we'll go for next reaction. This reaction was proceeding through free radical mechanism. Free radicals are formed, which is giving you the product. Okay. The next reaction, what I'm going to discuss, that is electrophilic substitution reaction. Electrophilic substitution also you have studied in first PUC. If you remember, we have done electrophilic substitution reaction for benzene. What are electrophiles? What do you mean by electrophiles here? What are electrophiles and what are nucleophiles? You tell me. First, you should know what are electrophiles. What do you mean by electrophile and what do you mean by nucleophile? Yes, very good. Correct. Electron deficient species are called as electrophile. They will have less electron with them. Correct. Electrophiles are electron deficient species. And nucleophiles are electron rich. Okay, these are electron deficient. Good. These are electron deficient and these are electron rich. Okay, these are electron rich. Who has more electron? Okay, they will be called as nucleophile. Who has less electron with them, they are called as electrophile. Yeah, so we are going to take an electrophile and do the substitution here. So we are going to do that to this methyl benzene. Okay, methyl benzene I'm taking as example. Okay, CH3 and then benzene, it is called as methyl benzene. And another name for them, common name, is toluene. Methyl benzene. Another name for this is toluene. Okay. Toluene, when made to react with the, we are taking this with the chlorine because you need halogen. No, we are preparing haloalkanes and haloarenes here. So this is basically to prepare haloarenes. So benzene compound is taken plus you are taking chlorine. Okay, and this reaction is carried out in the presence of iron as a catalyst and in a darker medium. Okay, because if you do this reaction in the presence of sunlight, it will cause free radicals to be formed. Okay, if free radical comes, they will come and replace this hydrogen. So you will not get haloarenes. Instead, you will get what you will get, benzyl. Benzyl compounds will be formed. Okay, this chlorine will not go and get substituted in the benzene. Instead, they will go and substitute these hydrogen which are present. Okay, so that is a problem which takes place. Due to that, we do this reaction in a darker medium. Okay, where sunlight is not provided to them. And this Fe, few molecules of Fe will react with chlorine. When you take Fe and Cl2, it is not that one Fe and one Cl is present. There will be thousands and millions of molecules of Fe and Cl2. Okay, so first this Fe and Cl2 will combine to form FeCl3. Okay, which will act as a catalyst here. FeCl3 will act as a catalyst, and that will help you to generate the electrophile. These FeCl3 will help you to generate the electrophile, okay, during the reaction.